Let's have a look at some hardware. The most important part of the MR machine is the main magnet, which has to be pretty strong to allow MR imaging. The strength of a magnet is given in Tesla or Gauss, where 1 Tesla equals 10,000 Gauss. Gauss was a German mathematician who was the first to measure the geomagnetic field of the Earth. Tesla is considered to be the father of the alternating current. He was a peculiar fellow, having refused to share the Nobel Prize with the inventor Thomas Edison in the early 1900s. Magnets used for imaging mostly have field strengths somewhere between 0.5 and 1.5 Tesla. As a comparison, the Earth's magnetic field is between 0.3 and 0.7 Gauss. The magnet of a refrigerator door has about 100 Gauss equals 0.01 Tesla. The magnetic field of MR magnets has to be very homogeneous, as it directly determines the precession frequency. Homogeneity is quoted in terms as ppm, parts per million, in a defined volume. To calculate this, the difference between maximum and minimum field strength is divided by the average field strength and multiplied by 1 million. How detrimental even rather small inhomogeneities, and thus differences in precession frequency, can be has already been illustrated in section 12. Homogeneity of the magnetic field can be improved by making some electrical or mechanical adjustments, a process called shimming. The large static magnetic field of an MRI system requires special facilities for the unit. It extends outside of the imager and can attract metallic objects and influence mechanical and electrical devices like computers, monitors, pacemakers, and X-ray units. On the other hand, there are also external influences. The whole air is full of radio waves. Just think about all the stations which you can receive on your radio. To prevent interference between outside radio waves and those from the MR unit, the whole system is shielded by a Faraday cage. Besides external RF generators, larger metallic objects, especially when moving, like elevators, cars, deserve to be mentioned, as they can influence the magnetic field.